Hi, math students. It's Mr. Hatchgasm here, and today we're going to be learning about standard form. And more specifically, we're going to learn how to convert ordinary numbers into standard form. Now, standard form is a way of writing very large or very small numbers. This is useful because some numbers are extremely large and some numbers can be extremely small. So for instance, if we talk about distance and the distance of planets, often those distances can be very large. So for instance, the distance from the Earth to the Sun is approximately 149 million kilometers. And this is quite a large number to work with. So mathematicians and physicists may prefer to use smaller numbers, and they may write this large number in standard form. Likewise, scientists who deal with atoms and bacteria, they might deal with very, very small quantities, and they may prefer to write those quantities in standard form because those quantities are very small. So let's see how this works then. Let's see how this works. Now, a number is said to be written in standard form if it is in the form of a times 10 to the power of n. So a is any number between 1 and 10. So this is a key fact to remember. A is any number between 1 and 10, and we can write this as a is any number between 1 and 10. So a is equal to or larger than 1, but less than 10. So this notation here just means a is any number between 1 and 10, but not 10 itself. So it can be 1, but it can't be 10. And n is any power of 10, which is a integer or a whole number. So n is an integer, which just means a whole number. So let's see how this works then. So converting 149 million kilometers in standard form, have a go at this question and see which one you will select. And you can pause the video at this moment. But the correct answer here is going to be 1.49 times 10 to the power of 8. So this answer is correct. Although this answer A is correct, B is correct, and C is also, A, B, these two should be the other way around. C is correct, A, B, and D are also correct. However, what we should notice is that here we said A has to be a number between 1 and 10. So a number between 1 and 10, well, 1.49 is between 1 and 10, but 14.9 is not between 1 and 10. So immediately we can rule this out. And even though it's correct, it's not in standard form. Likewise here, 149, we can rule this out because it's not between 1 and 10. And likewise here, 0.149, we can rule this out because again, it's not between 1 and 10. So automatically, hopefully you would have been able to realize that this is the correct answer because your A value is between 1 and 10. And then we have our n value, which is a index of 8. All right, so if we move on and see how we can write some numbers in standard form then. So we have 200. Now 200 normally wouldn't be written in standard form, but I've got this here just to see how we would write easier, smaller numbers in standard form if we ever had to. So 200 just means 2 lots of 100. Now I can rewrite 100 as a power of 10, and 2 is a number between 1 and 10. So this 2 is correct. So this becomes 2 times 10. Well, 10 squared is 100. So 2 times 10 squared is 200 written in standard form. Likewise here, 3,000 just means 3 lots of 1,000. So 3 is a number between 1 and 10. So the 3 is correct. And I can write 1,000 as a power of 10, which is going to be 10 cubed. So 3 times 10 cubed is the same as 3,000, except this is written in standard form. But again, with numbers like 200 or 3,000, we wouldn't really write them in standard form. Hopefully though, hopefully you would have noticed a pattern here. Now, let's look at the first non-zero integer. So the first non-zero integer, or the first non-zero number in the case of 200 is 2. After the 2, we have 1, 2 digits. Likewise here, our first non-zero number is 3. And after the 3, we have 3 digits. So what happens here is we write the non-zero number, and then we multiply by 10 to the power of however many digits we have after that non-zero number. So that's going to be 2 times 10 squared. So that power of 2 corresponds with the amount of digits we have after the first non-zero number. Likewise here, we have 3 digits here, so that's going to be 10 to the power of 3. Over here, so now that we have a larger number, well, this is going to be 3, because 3 is our non-zero number, and then I can write a line here, and then that's going to be 1, 2, 3, 4, 5, 6, 7, 8 numbers. So that's going to be, or 8 digits, so that's going to be 10 to the power of 8. Now here we have 37. So again, we need to write both non-zero integers. So we need to write 37 here. However, we said when we write numbers in standard form, our first number has to be between 1 and 10. So it can be 1, but it can't be 10. So this would have to be 3.7 times 10 to the power of something. Well, again, I need to draw a line here after my first non-zero number, and then we have 1, 2, 3, 4, 5, 6, 7 numbers, so that's going to be 10 to the power of 7. Likewise here, I need to write all my non-zero numbers, so 1, 3, and 5. But once again, 135 is not between 1 and 10. 13.5 is still not between 1 and 10, so this will have to be 1.35. And 1.35 multiplied by 10 to the power of, well, again, I need to draw a line after my first non-zero number, and then I just need to count how many digits I have. So I've got 1, 2, 3, 4, 5, 6, 7. So that's also going to be 1.35 times 10 to the power of 7. All right, hopefully that is starting to make sense. And hopefully we can do some more trickier examples. So let's have a look at these 2 examples here. Now we need to write 220 times 10 to the power of 6 in standard form. Now you may think, oh, this is already in standard form because we're multiplying a number by a power of 10. However, this 220, again, it's not a number between 1 and 10. So I'm going to rewrite this number in standard form. And 220 standard form, well, that's the same as 2.2 times 10 to the power of 2. So that's going to be 2.2 times 10 squared. And again, if we were to draw a line here after the first non-zero number, we'll have 2 digits after that. So that's going to be 10 to the power of 2 times 10 to the power of 6. And that will be equal to, and this is something you would have covered in the rules of, or you may have covered in the rules of indices, is that when we multiply 2 numbers that have the same base, so 10 and 10 being the same base, and they have indices, what we need to do is simply add the indices. So this is going to be 2.2 times 10 to the power of 8. Because we have the same base, we're multiplying the 2 numbers, so we just simply have to add the indices. Alternatively, you could think of it as 10 times 10 is 10 squared times 10 times 10 times 10 times 10 times 10 times 10. So I've got 1, 2, 3, 4, 5, 6. So that's 10 to the power of 6 multiplied by 10 squared, or I'm multiplying 10 by itself 8 times, So that's going to be 10 to the power of 8. 1, 2, 3, 4, 5, 6, 7, 8. But like I said, if we have very, very large numbers or very, very large powers, in that case, it might be a little bit tricky to list out all the tens or all the numbers that we have. So as good practice, it's important to realize that when the base is the same and we multiply two numbers, we simply add the powers. So with this case, our answer here is going to be 2.2 times 10 to the power of 8. All right, if I just rub this out, and here we have this example here. So 8,700 times 10 to the power of 7. Again, be careful. This is not written standard form because this number is not between 1 and 10. So I need to rewrite this bit in standard form. So that's going to be 8.7 times 10 to the power of a number times 10 to the power of 7. Well, again, I need to draw a line after my first non-zero number. So that's going to be 1, 2, 3 numbers after 8. So that's going to be 10 to the power of 3. And then what we'll end up with is 8.7 times 10 to the power of 10. So this number here written in standard form is 8.7 times 10 to the power of 10. And I'll just delete these just so you can see it a bit more clearer. All right, and moving on. So if I just rub this out and move on to the next slide. So what about really, really small numbers? So what we have here is a very small number, and that's 2 10-millionths of a millimeter. So it's a very, very small number, and it's unlikely that you'd have to actually say what this number is. And often scientists, so here we're talking about a hydrogen atom, the diameter of a hydrogen atom, would refer to this number in standard form. Now, before we write this number in standard form, I'm going to use a slightly easier example. So 0.2. Now, again, 0.2 is not a number that we would typically write in standard form because it's not extremely small. However, if we were to write this number in standard form, we could write it as 2 times, remember the first number has to be between 1 and 10, so this is going to be 2 times, and I'm just going to write 1 over 10. Because 2 times 1 over 10 is the same as 2 over 10, and 2 over 10 is the same as 0.2. Now, 1 over 10, so here's a rule that would be helpful to remember, and you will learn more about this again when you do rules of indices, but we can write 1 over 10, and I'm just going to write this over here. We can write 1 over 10 as 10 to the power of minus 1, and we can write 1 over 10 squared as 10 to the power of minus 2. We can write 1 over 10 cubed as 10 to the power of minus 3, 1 over 10 to the power of 4 as 10 to the power of minus 4, and so on. So with this example here, I can now rewrite 0.2 as, so 0.2 can be rewritten as 2 times, and 1 over 10 is the same as 10 to the power of minus 1. And I can write this number as 2 times 10 to the power of minus 1, and this is in standard form. Likewise here, so 0.02 is the same as 2 times 1 over 100, which will give us 2 over 100. Remember, 2 can be rewritten as 2 over 1. And when we multiply fractions, there are no funny rules. It's just multiply the numerators, multiply the denominators, and then we'll end up with 2 times 1 is 2, 1 times 100 is 100. So 2 over 100 is the same as 0.02. Now, I'm just going to move this up here. So this is the same as 2 times 10 to the power of minus 1 in standard form. So just going to rub this off. Now, 1 over 100 can be rewritten as 1 over 10 squared. So 1 over 100 is the same as 1 over 10 squared. Now notice what happens here. So we said 0.02 is the same as 2 over 1 times 1 over 100. Well, that's the same as 2 times 1 over 10 squared, which is the same as 2 times, well, 1 over 10 squared is 10 to the power of minus 2. So 2 times 10 to the power of minus 2 is equal to 0.02, and this is in standard form. So very important to notice that when we have small numbers, the power tends to be negative. And it's important to recognize this relationship here. And as you go up the key stages, so once you move on to key stage 4, you will learn where this comes from, why 1 over 10 squared is the same as 10 to the power of minus 2. But if you can just understand it or remember this rule for now, it'll be very helpful once we do more complex standard form problems. So as I said, the smaller the number, well, when we deal with small numbers, so numbers that are no longer whole numbers, but rather decimals, the power is going to be negative. Now, hopefully you'll be able to see another pattern here. So I'm just going to rub some of this writing out. Hopefully you will be able to see. Over here, this is our first non-zero number. And after our first non-zero number, we have 1 digit. So our answer is going to be 2 times 10 to the power of negative 1. So the 1 being 1 digit after our first non-zero number. Over here, our answer was 2 times 10 to the power of minus 2. So, whoops, once again, after our first non-zero digit, we have 2 digits. So that's going to be 2 times 10 to the power of minus 2. So going back to our example, so I'm just going to delete our animations. So the hydrogen atom and its diameter, well, this written in standard form, we need to write the number as 2 times. So we have 1, 2, 3, 4, 5, 6, 7, 7 digits after the 2. So that's going to be 10 to the power of, be careful, it's going to be minus 7 because this is a very, very small number. All right, let's do some examples then. So we have 0.01. Again, this is not a number that would be typically written in standard form. However, just to have some practice, we have 1, I'm going to write my non-zero digit, times 10 to the power of, well, this is 0.0 something, so it's going to be a negative power, and we have 2 digits after the 1, or rather I should say before the 1, so that's going to be 10 to the power of minus 2. Likewise here, this is going to be 6 times, and I'm going to count the digits, 1, 2, 3, 4, 5. So this is going to be 10 to the power of minus 5. Likewise over here, so now we have 72, so we need to write both non-zero digits. Now 72 is not in standard form. We said our first number has to be between 1 and 10, so that's going to be 7.2 times 10 to the power of minus something. So that's going to be 1, 2, 3, 4. So that's going to be 10 to the power of minus 4. Likewise here, we have 941. Well, that's going to be 9.41 times 10 to the power of, and again, after the 9, how many digits are there? There is 1, 2, 3. So that's going to be 10 to the power of minus 3. And likewise here we have 115. So that's going to be 115, which will give us 1.5 times 10 to the power of minus something. Well, we have 1, 2, 3, 4 numbers there. So that's going to be 10 to the power of minus 4. And lastly, if we do some more examples, which are a bit more complex. So 0.007 times 10 to the power of minus 4. Now notice this number here is not in standard form because it's not between 1 and 10. So I need to rewrite this between 1 and 10. So that's going to be 7 times 10 to the power of minus 1, 2, 3 digits. So that's going to be minus 3 times 10 to the power of minus 4. And now notice we have the same bases here. So all we need to do is add the powers. So that's going to be 7 times 10 to the power of, now minus 3 plus, or I should say minus 3 plus minus 4 is the same as minus 3 minus 4, which will give us minus 7. So that's going to be 7 times 10 to the power of minus 7. Right, boys and girls, I hope you found this useful. And that's it for today's lesson. So the key takeaways here, we write numbers in standard form if they are very, very large or very, very small. Now with small numbers, such as 0.01 or 0.00006, our powers are going to be negative. Whereas with the very, very large numbers, as in the case of the distance from the sun and the earth, the power is going to be positive. Right, I hope you found this useful and I wish you a very nice day. Thank you and bye.